What's up, Accelerated Algebra 2, Stirp here. And so we're going to be working with these functions that when you get a whole, um, and a whole is a different thing than an asymptote. An asymptote is basically going to do something like this, and a whole would actually be a whole where the slope doesn't really change um, on each side. So the slopes are equal on either side, whereas an asymptote, the slope gets more and more and more, or less and less and less, depending upon what direction it's going. Um, that's kind of a calculus thing for y'all. All right, so we're just going to start simplifying these expressions. So nothing to factor out on top. So I have 3x squared on top. On bottom, I can factor an x out, and then I have x plus 2 and x minus 2. And then with that, I can go ahead and cancel out an x. So I have 3x left on top and x plus 2 and x minus 2 left on bottom. And some people say, should I multiply that back together? When you're factoring it out, you want to keep it just as factored form. All right, number 2, x plus 2, or excuse me, x plus 5, x minus 5 on top. And on bottom, I get x minus 6 and x plus 5. And the x plus 5's cancel out. And this is actually where we're going to create a whole, but we'll see that in a few slides, what happens there. So that's our answer. You can keep both the top and bottom in parentheses so you don't go cancel anything out that shouldn't be canceled. Bottom one, I'm going to get x minus 8 and x minus 4 on top, and on bottom, that's going to factor to x plus 8 and x minus 4 on bottom, where the entire binomial of x minus 4's cancel out. So I'm left with x minus 8 over x plus 8. Hope you're all doing well. Let's see. Next one, top's going to factor. I can factor an x out, and then that would be x squared plus 7x plus 12, which factors to x plus 3 and x plus 4. And on bottom, I can factor an x out as well. And then I have x squared minus 2x minus 15. So that's x minus 5 and x plus 2. And the x's cancel out and nothing else cancels. So we just have an answer with the x plus 3, the x plus 4, the x minus 5, and the x plus 2. And again, keep it in factored form. No reason to put it back. Okay, so check for wholes. Factor both the numerator and denominator. Simplify the function, but note the x value for any factors that are simplified. To find the coordinates of the whole, substitute the x value from the simplified factor into the simplified function to find the y coordinate. You're like, what? Yeah, it will make sense in a sec. All right, so I'm going to factor the top. And the top would be x squared minus 16, so that's x plus 4 and x minus 4. And then on bottom, the bottom's going to factor to x plus 9 and x minus 4. So the x minus 4's cancel each other out. So that x minus 4 gives me an x value of 4 for where my whole is going to exist. I'm going to take that 4 and I'm going to plug it back into my simplified version. So I get 4 plus 4 is 8, times 2 is 16, so I get 16 on top. And then 4 plus 9 is 13. So I have a whole at the coordinates 4, 16 thirteenths. Number 6, I'm going to factor the top to x minus 5 and x minus 2. And on bottom, it factors to x minus 5 and x plus 2. And the x minus 5's cancel out. So that gives me a whole at 5 comma, notice it's opposite value. So if you set that equals 0, take that 5, plug it back in. 5 minus 2 is 3. 5 plus 2 is 7. So 5 comma 3/7 is going to be a whole. And again, if you guys need a Zoom, send me a text and we can set up a Zoom meeting. Happy to meet with you. I've not had as many Zoom meetings in the past week or two, so I'm happy to set something up. Just send me a text when you want to do it. Okay, so now we're going to get ready to start graphing these. So this factors to x plus 4 and x minus 4 on top, and on bottom that factors to x minus 4 and x plus 9. I think we already did this one, but we're not going to graph it. So we're going to cancel those out. Okay, so my hole is going to be at 4 comma something. So I'm going to plug 4 back in. So 4 plus 4 is 8, times 2 is 16, and then 4 plus 9 is 13, so 16 over 13. So I have a hole at 4 and then 16/13, which is just above 1. So I kind of have like a hole right there. Okay, I don't know exactly how the graph's going to look, but that point doesn't exist when I graph it. Okay, I have a vertical asymptote at x equals -4. I get that from here. So -4 is here. So I get my vertical asymptote still there. And then my horizontal asymptote, the degree on top and the degree on bottom are equal, so I'm going to take the lead coefficients. So I'm going to get y equals 2 over 1, or just 2. So y equals 2. So this is my nice straight line. Geez, Louise, I'm doing well. X-intercepts. We should be able to find an x-intercept no problem. Just basically take the top and set it equal to 0. So 2x plus 4 equals 0. Divide by 2. So x equals 4. So I get -4 comma 0. So negative, oops, did I do that wrong? -4, -4, x-intercept. Hang on, I think I goofed up. -4. Okay, so I guess we have an x-intercept right here. So it kind of dorks around with that. Our y-intercept is going to be plug 0 in for our x's into the original. So I'm going to get -32 over -36, which is positive 32 over 36 will reduce to 4 goes into both, 8 over 9. So 0, 8/9. So I get a point right there. Okay. So a few things. This graph is going to kind of, let's pick a couple of values just to make sure. So let's pick, say, -5, just because that's over to the left of that asymptote. If I take -5 and plug it in, that becomes 25. 2 times 25 is 50. 50 minus 32 is 18. -5, so I get 25. Minus 25 is 0. 18 over -36. So I get -½ So that should guide us along what this graph's going to start looking like. So -5, -½ is right in here. I think we have kind of what this graph is going to look like. This graph is going to do this. It's going to skip over that hole, and it's going to probably go down from there. You can double check that on Desmos. So I might be off a little bit, but we have the hole correct, and we have the x and y intercepts correct. Oh, you know what? I know where we made a mistake. My vertical asymptote should have been at -9. Sorry about that. So this was not here. That makes me feel a lot better about what this looks like. -9, so we go down this way. There's my vertical asymptote, so this would have done this, where you have the hole right there. Perfect. It's very possible this graph also exists over here like this. Okay. I'm not in class, so you guys can't correct me fast enough, but I bet you some of you were able to correct me saying, wait, you messed up on that vertical asymptote, you know. All right, so let's factor the top. Top's going to factor to x plus 6 and x plus 2. The bottom's going to factor to x plus 9, x plus 2. So my whole, my x plus 2's are going to cancel out, so my whole is going to be at -2. Plug -2 in what you have left, so -2 plus 6 is is 4. -2 minus 9 is -2 minus 9 is 7, so 2 comma 4/7. So -2 and 4/7. So somewhere in there is a hole. Vertical asymptote, we're going to get this one right, maybe. So it's going to be at x equals -9. So it's way over here. Horizontal asymptote, the degree on top, degree on bottom are the same, so the lead coefficients are 1 over 1, so y equals 1. Okay, x-intercepts. If I plug 0 in, I'm going to get a -6, 0. So I plug 0 in for y and solve it. So -6 zeros right there. Y-intercept, if I plug 0 in for x, I'm going to get 12/18, which reduces to 2/3. So 0, 2/3. So somewhere in there. So this graph is now going to kind of look like this. It's going to come along here. It's going to skip over our hole. It's going to come down. It also probably would exist over here, but that's kind of way off our grid. So we just note that we have a hole right there. If you had graphed this on your graphing calculator, you can't see a hole, but if you go into the table, you would see at -2 that would say error. And that's where that would exist. Okay, next problem. Let's factor at the top. I'm going to get x minus 5 and x minus 6. Bottom, I could factor 3 out, and I have x squared plus x minus 30, so that's going to give me an x minus 5 and an x plus 6. Come on, squeeze in there. The x plus minus 5's cancel out, so at 5 comma something, take the 5, plug it in. 5 minus 6 is -1. 5 plus 6 is 11. 11 plus, or 11 times 3 is 33. So 5, -1, 33rd. So that's really close to the x-axis. So got my hole right there. Vertical asymptote. So we're going to take a look at this. That was x plus 6. So vertical asymptote is at x equals -6. Just double check my math. Did I do that right? Yeah, okay. And then my horizontal asymptote, the degree on top and the degree on bottom are the same. So I'm going to take my lead coefficient, so I get 1/3. So 1/3, it's like barely up above here. And my x-intercept, I'm going to wind up with 6. Is that right? 6, 0. I goofed this problem up. I didn't factor right. So let's, I'm going to start back over. I apologize. So the errors in the video, never said I was perfect. I think you guys knew that, but that's okay. Appreciate your grace. So top factors to x minus 6 and x minus 5, right? Did I do that right? Yep. Okay, that checks. Bottom is going to factor to 3. And then I had x squared plus x minus 30. So I have plus 6 and minus 5. Oh, lo and behold, I have a hole at 5 comma something. So we're going to take 5, plug it back into here. So I get 5 minus 6 is -1. 5 plus 6 is 11. So I get 1/33. I don't know if that's what I had originally or not. So 5, -1/33, that's down here. Vertical asymptote, take what I have left. I'm going to get 6, comma, or negative, vertical asymptote is going to be the bottom set equals, so x equals -6. Horizontal asymptote, degree on top and degree on bottom are the same, so I got 1/3. So I had some of that right, but I made an error. I apologize. X-intercepts are going to be at 6, 0, because you would look at this right here. So 6, 0 is right here. That's going to work out a lot nicer for us. Y-intercept, if I plug 0 in for all my x's, I get 30 over -90, which is -1/3. 0, -1/3, so this exists. So my graph is going to come along here, jump over my hole. swing on down, and then it's going to also exist over here where I had a hole right there. Okay, I think we did this right now. Yay. And last problem. Okay. Top is going to factor to x plus 2, x plus 4. Bottom is going to factor to x plus 4, x minus 3. So I have a hole at negative 4 because these cancel each other out. Plug the negative 4 in, so I get negative 4 plus 2 is negative 2. Negative 4 minus so negative 7, so 4 comma 2 sevenths, negative 4 comma 2 sevenths, so, or positive 2 sevenths, so it's right here as a hole. Vertical asymptote, I'm going to look at that, and that's going to say that x equals 3. Horizontal asymptote, degree on top and bottom are the same, leading coefficients are 1, so it's 1 over 1. X-intercept, I'm going to look here, so it's going to give me a negative 2 comma 0. Negative 2 comma 0 is right there. Y-intercept, I'm going to plug 0 in for all my x's, so I get 8 over negative 12, which is negative 2 over 3. So that's there. So this one comes over here, jumps over the hole, comes down, and exists up there like that. So I have my hole right there. Okay, take a look at the problems. I should have videos posted. I think Mrs. Peterson or Miss Schumann-Smith put together the videos on the homework on this. So double check that. And again, if you want to Zoom, let me know. Have a great day. Take care of one another.